Hello and welcome to day 13. So today's input is a series of grids. Each grid has a mirror location somewhere in it. So like in this particular case, it's here. So these two columns are identical, and then their adjacent columns are identical, and then the next adjacent columns are identical, and so forth until we run out of input. So like this first column doesn't have a match on the right side, but we can ignore that because there's just no input. So that's our location. The mirror could also be horizontal. So in this particular case, it's after this line these two lines are identical. And then again, the first one gets ignored, but all the rest of them match up. They mirror horizontally. So all we need to do is basically figure out where that mirror is. They're going to always be one vertical or horizontal mirror, not both in part one. So pretty easy to go through. So the first thing I decided to do was break those checks into just separate pieces just to make it quicker and easier for me. So I made a function for horizontal and vertical. I decided to do horizontal first because that seemed a little bit easier. So our grid comes in as a list of characters. And then basically for one before the grid size, so we're not going to check the mirror before the 0th column, and we're not going to check it after the last column because there's nothing to reflect on one side. So everything in between, we're going to find out how many rows of reflection we have. So like if it's a 10 by 10 grid and we're on like row 3 or whatever, I don't want to check more than, I only want to check 3 rows down. Or if I'm on row 7, same thing, I only want to check 3 rows up. There's no reason to check more than that because we're going to hit the end of it. And then basically just set match true, and then for each row in the min rows above and below it, if they match or if they don't match, we break. If they do match, we continue on to the next set and the next set and the next set until we either hit a row that doesn't match or we hit the end of our rows that we need to check. And if it does match, then that's our answer, return it, we're good. So then vertical is basically the same thing. But I had to make a slight change where instead of I'm changing or checking by the row, I have to map each column out of the grid. So it's pretty simple. The map operator is just going to say, all right, I'm going to make a new list of the I minus R item of each row. Other than that, logic is exactly the same. So to do our actual answer, then all we need to do is basically map a grid out for each grid, and then add our vertical and our horizontal times 100, which is the way they wanted the input. So pretty simple on that part. Part 2 gets a little bit trickier. So the idea is that now there is a smudge somewhere in there. So there's some character that you could change from a dot to a hash or a hash to a dot and get a different mirror. So that mirror may, only be on the edge. It may, be a horizontal instead of a vertical, or it could be a vertical. It's just further on. So it's just there's guaranteed to be now an additional one, and the first one may or may not even match anymore. And then what we want to do is we want to find that new location. We had done this a slightly different way, where instead of trying to find or instead of just saying if the lines were equal, if we actually counted up how many things were different, then I think some solutions I've seen where you would basically just look for differences of 1. So you have like a total number of differences, and if that's 0, then it's the same one. And if it's 1, it's a different one. If it's more than 1, then it's not a smudge. I didn't do it that way because the way I had done it originally, I was just checking the whole rows and whole columns together. So what I did was just made a quick smudge function, which basically I got my initial vertical grid, my initial horizontal grids, like the ones from part 1. And then for every item in grid, which this is usually a very bad way to approach part 2, because part 2 is very frequently just a lot more data. But in this case, our test file was so small, like it wasn't really going to matter. So for every item in the grid, I'm going to try to flip it from one to the other, and then I'm going to go find a new mirror. And if there's a new mirror, then I return it, and if there's not a new mirror, then I swap my things back so I have my data ready for the next time, and then iterate through until I hit the end of the grid. So I had to make one small change here, and then I also sent in this initial spot. And so if we go back up here, I skipped over this the first time, but I have an original for both of these that just is set to -1 normally, and we only check that row if it's not the original. So like if it was 3, 3 may or may not still be a mirror, but the problem is if it is a mirror, we may need to continue checking. So like if the new mirror is also a vertical mirror, and also, or just happens to be further along the path or whatever, then I don't want the other one to return early. Anyway, not the fastest approach, I'm sure, but it's still pretty quick considering the size of the data. Like 60 milliseconds, I'm not gonna complain. That's perfectly fine. Yeah, so that's basically it. If you have any questions or comments, of course, drop them below. News code will be in the GitHub. And other than that, I'll see you tomorrow.